Welcome back to the lecture series of Computer Organization and Architecture, unit number 4, Memory Organization, and today's topic is Virtual Memory. Learning outcome is describe the cache and virtual memory. Now first, what is virtual memory? So in a memory hierarchy, uh, programs and data are first stored in auxiliary memory, and portion of the programming data, programs or a data are brought into the main memory as per the requirement. So this virtual memory is a concept used in some large computer system that permits the user to construct a program as though a large memory space were available, and that is equal to totality of auxiliary memory. Means virtual memory is used to give a programmer an illusion that they have a very large memory, even though the computer actually has a relatively small memory. So virtual memory system provides a mechanism for translating program generated address into the correct main memory location. So here each address that is referenced by CPU goes through an address mapping from the so-called virtual address to the physical address in a main memory. So this by using virtual memory, it will provide illusion to the programmers, and all this mapping is done automatically, or you can say the dynamically by the hardware, by using mapping table. Now some definition, that is address space and memory space. So first definition I'm sorry, first definition, that is for the address space. So an address used by a programmer will be called as a virtual address, and that is, the set of these kinds of addresses are known as the address space. Then second one, that is memory space. So an address in the main memory, that is called as a physical address, and set of such addresses or the such location, that is known as memory space. So these two words, address space and memory space, both are important for a virtual memory. I am repeating it. The set of virtual address space, that is known as address space, and memory space, that is set of physical address, that is known as memory space. Now program stored into the secondary storage, that is partitioned into several pages and segments, and then taken few pages, means whenever you will store your programs in main memory, then it will take few pages from that pages into the main memory. Once those pages in main memory get executed by the processor, now new pages are taken from the secondary storage into the main memory using different page replacement algorithm. So using this method, means using this virtual memory, large program residing in secondary memory can be executed by using the small main memory. So thus virtual memory create illusion to the programmer. So in most the computers, the address and the memory space are identical. So the address space is allowed to be larger than the memory space in a computer with the virtual memory. Okay, so if your computer supports the virtual memory, then and then you can do this. Otherwise, this memory space and address space, that is identical, means both are same if your computer not supporting the virtual memory. Now we will see the one example. So here you can see this is your auxiliary memory and this is your main memory. The size of auxiliary memory is always greater than the main memory. So here the size is 1024K. It means 20 bits are required to identify the any word. Okay, means your address is made up of 20 bits. This virtual address is made up of 20 bits. Then this is your main memory. Main memory means this. Here you have a physical address, and physical address that is made up of 15 bit. So this is your memory space. This is your address space. Okay. So now whenever suppose if you want to execute program number one, then this program number one is divided between the different pages and segments. So few pages will be copied into the main memory. So right now we have copied data 1 comma 1 into the main memory. Now here all this data means all these reference instructions and data which have a 20-bit address, but the information at this address must be taken from physical memory because access to the auxiliary storage for the individual words will be very long. So here this address of this one will be 15 bit, but internal addresses which is made up of 20 bits. So here whenever this main memory execute this code, and then whenever it requires this data 1 comma 2, then it will send the 20 bit address to the auxiliary memory. This data is required and it will reply back with the said data. Now see, here in auxiliary memory, this address is made up of 20 bit, but in main memory, this address is made up of 15 bit. So to map this address, we required mapping table. Okay. So the CPU will reference instructions and data with a 20-bit address, but the information at this address must be taken from physical memory because access to the auxiliary storage for individual words will be prohibitively wrong. Okay. So we required one mapping table which will map this 20 bits to 15 bits. So this mapping table can be stored into the memory or can be stored separately. So this is the case in which additional memory unit is required to store this memory map table. So this is the first case in which we have a separate memory management table is there. Means so you can see in this diagram. See, whenever you will pass virtual address, this virtual address means this is the address from your address space. So that is made up of 20 bits. This address will be given input to the memory mapping table. Now this memory mapping table will identify the 15-bit address related to this mapping table. So this is the hardware in which you can find out the 15-bit address. Now this 15-bit address will be sent to the main memory address registers, and based on this memory main address register, this main memory get the data as well as the memory location. Okay, so in this kind of representation, you required just only the one memory access at a time. Now in the second case, the table takes space from the main memory and two accesses to the memories are required with the program running at half speed. So instead of doing this separate thing in main memory, this memory mapping table will be stored, and thus you can access this memory mapping table. Now whenever your CPU executing the code and whenever it will require data that is not available in main memory, so at that time page fault is occur, and this page fault means what? The said page is not available in main memory. So now main memory will communicate with the secondary memory, and secondary memory will secondary memory means from your virtual space, or you can say the address space, this page will be copied into the main memory. So this during this page fault, there are different kinds of page replacement algorithms are used to replace the page. So for that we have first in first out, that is FIFO, or you can say the FCF as first come first serve, and different kinds of page replacement algorithm are used.